Okay, pre-calc. As promised, this will be the last installment for the exponential log equations section 4.4. So hopefully this will help you to finish out your exercises. Again, just try your best. You know, I understand you're not going to be able to get every single problem correct at first, but just give it a good try. Remember, they're due on Monday. Just take a picture of the assignment and send it to me. So what we're going to look at here is how to solve an interesting class of exponential equations that require something called substitution, or as I call it, a U sub for short. So here's such an example. E to the 2x minus e to the x minus 6 equals 0. So this is an interesting equation because we have e's on one side and we have 0 here. So this takes the form of something that looks quadratic, doesn't it? You have an x squared type of thing, some kind of e to the x, a constant. So there's a trick to doing these, and it's this process called substitution. And what I want you to realize is that something like e to the 2x, you could rewrite that in a way like this. You could think of it as e to the x squared. Okay? Now think about that for just a second. It should make sense to you. And this is going to be a very important concept to do a problem like this and the ones as we go forward. But if you have e to the 2x, isn't that the same as saying e to the x raised to the 2 power? Because your properties would tell you that x times 2 is 2x, right? Power to the power. So this is going to be the backbone to doing a problem like this. So here's how we do it. What we're going to make is the substitution. We're going to say, let u stand for e to the x. So we typically go after the middle term when we do this. U is just going to stand for some variable. We want to make it easier. We'd rather solve an equation that has a u than an e to the x, right? So what is our new equation going to look like? Well, this is what it'll look like. That middle one will be just the u, so there's the minus u, minus 6 equals 0, that doesn't change. But this is where that trick comes into play. This is going to be now u squared. Because remember, if u stands for e to the x, if this is e to the 2x, that means you got u squared. So your new equation that we're going to solve is u squared minus u minus 6 equals 0. And you should be very happy to solve something like this instead of something like that. Okay? So again, we made this substitution right here. U is e to the x. We typically go after that middle term. Now let's go ahead and solve this. This is a very good factoring problem. Factors of 6, it's either going to be 3 and 2 or 6 and 1. But we have a minus 1u in the middle. So that means that we're probably going to have to go with 3 and 2 because 3 minus 2 would give you a 1, or we could think of it as negative 3 plus 2 is negative 1. So we're going to make that minus 3, and that'll be the plus 2. And just like before, we set the factors equal to 0 when we solve it. So here you're going to get u is negative 2, u is minus 3. Now here's the thing. We're not done with the problem because this problem started out with x's. We solved the problem that had u. So what we got to do is remember this substitution that we made and go back and figure out what the value is and plug them in. So when u is e to the x, if u is negative 2, that means you got negative 2 equals e to the x. And now we have to solve this. This is an exponential equation. So you remember how this is handled. You're going to take the ln of both sides. So over here, ln e to the x, that's just x. But this should sound an alarm for you. This is a problem. ln of negative 2. If you remember, again, logs can take on negative values as inputs. So this is bad. So we throw this u equals minus 2 out. It's not going to be part of our final answer. But let's check out u equals the value here of positive 3. So now we're going to have 3 equals e to the x. Take the ln of both sides. This means that ln of 3 equals x. And this will be the answer that does it for us. And if you check it out, back in the original equation, you see that this will work for us. So your solution set for this problem is ln of 3. Of course, you can write the decimal equivalent for that, as your textbook usually does in the back. Okay? So I know this is kind of wonky, but this is a very good procedure that works a lot of the times for us. So let's just go back and reiterate. We had an equation that's somewhat in quadratic form. What we do is make the substitution for this middle term, which is e to the x. When we make the substitution, we get u squared minus u minus 6 equals 0. That is our new equation. We solved it for u. Then we have to plug the values of u back in to where we made the substitution and solve them. We saw that when we do that here, this doesn't work. So u equals negative 2 is thrown out. But when we plug in 3 and solve it, we get the ln of 3 is x, and that does work, as you would see. So your solution set here for this equation is ln of 3. So why don't you pause the video, go back, see if you can do the problem, and we'll do one more example. Next one will be from the textbook, which you have to be a little more creative about. Okay, welcome back. Okay, so the next example is one that is right from your exercise set in the textbook. This is number 45. We have 3 times 4 to the 6x power equals negative 10 plus 17 times 4 to the 3x power. So holy cow, right? This is a whole bunch of garbage, isn't it, right? This is really weird compared to the last equation. The last one seems a little bit more normal, right? But we want to proceed kind of the same way though. We want to get the things with the exponents on one side, and we want to set it equal to 0. So the bare minimum, let's at least all be able to do that. So we have 3 times 4 to the 6x power minus 17 times 4 to the 3x power plus 10 equals 0. So you see what I did? I just brought everything over to the left, set this equal to 0 because that's our game plan. Now, you gotta be a little bit creative with your substitution here. Now, think about like in the last problem, we had e to the x and we had an e to the 2x. So the same thing here is we're gonna wanna let now u be what's in the middle. So u is gonna be 4 to the 3x power. So what that means for this guy is, this is 4 to the 6x. Remember how we could write 4 to the 6x? We could write that as 4 to the 3x raised up to the 2, right? You see that? So 4 to the 6x can be written as 4 to the 3x raised up to the 2. And that works out perfectly because look what your u is. U is 4 to the 3x. And that's what we have right here. So again, pause the video if you need to think about this idea, but this is how you have to think. It's like working backwards from the stuff that you learned in the beginning of the year. I'm back in Algebra 1, Algebra 2. So let's go ahead now and put everything together. So we're going to have 3u squared minus 17u plus 10 equals 0. So here's your new quadratic equation. Again, this is not bad at all. We're going to be able to solve this by factoring. So one of them is going to be 3u, the other is going to be u. It's a minus followed by a plus. That means both of these need to be a minus on the inside. And we need factors of 10 that somehow when we do multiplying here, we're going to get a minus 17 in the middle. Well, it's either going to be 2 times 5 or 10 times 1. Now, you should be able to think through it. We're going to go at 5 times 2. We're going to put the 5 here and the 2 there. And if you go and do your FOIL technique, you'll see that that yields the negative 17 in the middle. So we're going to have 3u minus 2 is 0, and u minus 5 is 0. And we'll go ahead here and solve them. Over here, you're going to get u is 2/3, and over here, you're going to get u equals 5. Okay, so that's again solving for u. And now, just like in the last problem, we got to go and see what are these values, what they're going to give us for x. Now remember, these types of things, one of them could work, both of them could work, neither of them could work. So, you know, it's that the possibilities are there. So let's check out 2/3 first. So if we have u as 4 to the 3x, that means we got 2/3 equals 4 to the 3x power. So to solve this, we'll take the ln of both sides. So you got the ln of 2/3 equals the ln of 4 to the 3x, right? ln of 2/3 is, remember our property, if you have ln x to the r, that's r ln x. So essentially the power just plops right down in front. So that's 3x times the ln of 4. What we're going to do here is divide both sides by 3 ln 4, because remember, those things are just numbers. So ln of 2/3 over 3 ln 4 is x. Now, I will spare you the time. This does work, but make sure you check it out in your calculator. This value will work. I would encourage you to get a decimal for this and before you plot that back in the original. The second one is going to be 5 equals 4 to the 3x. So what this is going to be is we'll take the ln of both sides again. So we have the ln of 5 is 3x ln 4. See, isn't this fun? This is really fun. You're stuck at home, what better to do than solve equations, right? Divide both sides by 3 ln 4. So we get ln 5 over 3 ln 4 equals x. And I will tell you, to spare you the time, that does work as well. And this equation has these two solutions. So both of them are workable solutions. Okay, so this one's a little bit more challenging, but again, I think if you go back, pause the video, redo the problem, you'll get it. With that being said, that closes section 4.4. So now you have all the tools in your arsenal to do the exercises that I gave to you. Again, if you have any questions, please call, email, send me pictures of your work if you need help. I'm more than willing to help you with this as we learn from distance. So until next time, I hope you stay healthy and well and safe, and enjoy the rest of your Friday.